Hello everyone. Today I'm gonna present my project Decoding Watching Desire from fMRI signals during movie trailer watching. As we all know, movies offer a unique medium for exploring diverse perspectives, cultures, and narratives. And it also facilitates the sharing of emotions and stories on a broad scale. And movie trailer offers the movie producer a very special unit to attract audiences before like the release of the movie. So to know like whether the participants, whether the audiences are excited or w love to watch the movie during movie watching the movie trailer period is really important, takes a very critical role for us to understand whether the movie is gonna turn too popular or not. Our project investigates how fMRI signals can predict watching desire when subjects view movie trailers. So I actually built a machine learning model using fMRI data to decode the neural patterns associated with the decision making and emotional responses while participants watching the movie trailers. So by leveraging effective neuroscience principles, I analyzed how brain activity relates to approach and avoidance behavior using machine learning and deep learning method. And my results showed that the key brain regions, including the nucleus accumbens and anterior insula, play a role in predicting movie watching preferences. And this study provides insights into neural mechanism of consumer choices and has potential applications in film marketing and entertainment analysis. So for the experiment, we built an fMRI study and we collected data from 27 subjects. They engaged in a movie watching task, actually trailer watching task, while undergoing functional magnetic resonance imaging scanning. And during each trial, subjects are supposed to watch like at a comedy or a horror movie trailer, and followed by rating prompts to indicate their desire to watch the movie and affective valence and arousal. So, after pre-processed data with the motion correction, normalization, smoothing, and something like that, we gathered data like from extracted from the regions, the brain regions of interest, and the data set includes like the whole brain, well, different brain regions. fMRI signals was 21 TRs, which is actually 42 seconds per trial across 32 trials of study, and each rows representing subjects and the columns corresponding to the TRs and the brain regions and also their behavioral responses. And two methods to experiment I tried, or like one is the ensemble classification method with for the volume of interest, the region of interest analysis. Here I use a combination of logistic regression and XGBoost, which is a gradient boosted decision tree model, and I use the Hartwell method to combine the two together. And then I use a 3D convolutional neural network method for the whole brain analysis. And this is a deep learning classifier after, well, I try to first extract the spatial, both the spatial and temporal patterns from the fMRI volumes, which is the whole brain fMRI signals actually. And I did some like global average pooling and fully connected layers and eventually classify like whether they want to watch or not with the whole signals. So for the ensemble model, it's actually slightly or moderately has a prediction accuracy higher than the random model, which is 56%. It's 56 for, well, which is for 57%. And for the 3D convolutional neural network model, it actually highly outperforms the ensemble model and reaches the accuracy to like 59% or 60%. But when we zoom into the confusion matrix, we actually are able to see that the precision is always higher than the recall due to the prediction bias towards the not liking or doesn't want to watch category. Even though like I balance all the category labels ahead the two methods of training. And For the training curves for the 3D convolutional neural network, we are able to see like during this like 15-ish training epoch, the 3D CNN model didn't show like a very like sharp overfit or whatever. It actually fits the data very well and it keeps training to reduce the losses. And well, as we know, the ensemble model was the combination of logistic regression and XGBoost achieve like a moderate accuracy, like performing better that on the non-preferred movies, highlighting the class imbalance. And the 3D convolutional neural network model significantly outperformed the traditional models by learning the spatial temporal patterns. And the prediction bias persists despite the balanced class distribution, and it might indicate that a model is overfitting to like specific neural correlates of one preference type. So maybe I should rethink of like um renormalize my whole brain data. And the future representations learned by the deep models may be skewed toward dominant signals, variations, and overlooking some like subtle neural differences. And for the future research, I wish I can enhance the model robustness via hyperparameter tuning and more techniques, more methods, and expanding the data sets through data augmentation or transfer learning or just collecting more data and incorporating like transformer-based architectures or recurrent neural networks to better attract the temporal modeling. Well, that's it.